Hello students, welcome to the class of physics. Let us start the chapter 8, motion. What we are going to learn in motion? We can observe that the objects surrounding us are taking a movement from here and there. So we can see that objects are in motion. So in chapter 8, we are learn the basic principles of motion. In everyday life, we see some of the objects are rests and other are in motion. Like birds fly, fish will swim, blood will flow through our veins and arteries, and cars are moving. We often perceive an object to be in motion when its positions are changed with respect to time. What causes the phenomena of sunrise, sunset, and the changing of seasons? It is due to the motion of earth. If it is true, why don't we directly perceive the motion of the earth? An object may appear to move for one person and stationary for some others. For the passengers in a moving bus, the roadside tree appears to be moving backward. A person standing on the roadside perceives the bus along with the passenger as a moving. However, a passenger inside the bus sees his fellow passenger to be at rest. So, these are the different observation we had. Why it happens? So, in this chapter, we will first learn to describe the motion of the object along the straight line. We also express the motion through the simple equations and graph, and later on we will discuss the way of describing the circular motion. What is motion? An object is said to be in motion if it changes its position with respect to its surroundings in a given time. As an example, suppose you are walking. When you are walking, you are changing your position with respect to one stationary situation. So, you can say that you are in a motion. Motion is always observed and measured with a point of reference. All living things show motion, whereas non-living thing shows motion only when some force is acting on it. We will learn the different types of motion. The first is translatory motion and the second one is circulatory motion. Translatory motion. See the pictures below. What you can see? A car and a bicycle. Both are moving in a straight line. But a car is changing its position with respect to one of the stationary point on the road, and the bicycle is also changing its position with respect to stationary position on the road. But the passenger in a car and the passenger on bicycle, for that the each other are observed as a stationary, because they both are moving with a constant speed. In the second figure, what you can observe? The apple is falling from the tree. Earlier the apple is on the tree, and after some time the apple is falling on the earth. So, it is changing its position with respect to time and with respect to one reference point. So, what you are learning from this? That the motion must be described with some reference point. Now, we learn the types of translatory motion. There are two types of translatory motion: rectilinear motion and curvilinear motion. See the pictures below. In the left side, you can see that all cars are moving in a straight line. In the second figure also you can see that the persons are moving in a straight line. But in the second figure, what you can observe? The car is moving on a path which is curved in a shape. So, we can define, if a body moves in a straight line, it is called a rectilinear motion. But if a body moves along the curved path, then it is said to have a curvilinear motion. Second is the circular motion. See the pictures of a merry-go-round. Hope you all had enjoyed this merry-go-round in your childhood. So, what you can observe while sitting on a merry-go-round? You are taking a round of a single pole. So, that called as a fixed point. So, a circular motion can be defined that an object is said to be in a circular motion where it moves around a fixed point, which is called as an axis. Let us learn the different types of circular motion. First is revolution and second is rotatory motion, or we can say it is a rotation. See the pictures below. And the first figure, you can see there is a sun and earth. Earth is taking a complete round around the sun. So, what we can say, whole earth is as a whole taking a round around the sun. So, we can define a revolution that when a body as a whole moves in a circular path, its motion is called a revolution and the body is said to be revolving. In the other three figures, what you can observe? The earth is rotating around its own axis. In the other figure, you can see there is a windmill. There is another simple example, that a simple fan in your home. You can see that all the wings of the fan are taking round around a fixed point. So, we can say that fan is having a rotatory motion. In the third figure also, that a doll is taking a round around its axis. So, when a body undergoes a translatory motion in such a way that its part cover the different distance in a given time, it is said to have a rotatory motion. Another types of motions are oscillatory motion. A pendulum of the clock. Try to observe the pendulum of the clock and observe its motion. It is making to and fro motion. Similarly, the other figures is a swing, simple swing, that again all you had enjoyed in your childhood. So, what is the oscillatory motion? When a body taking a movement of to and fro about a fixed point, it is said to be a oscillatory motion. Another are called as a vibratory motion. In simple way, we can see it is a vibration. Sometimes the whole object does not show the to and fro motion, but the part of its body, it shows the motion of to and fro about a fixed point. Such a motion is called as a vibratory motion. This motion is actually a very fast to and fro motion. You had observed the guitar, sitar, tabla, all these things, musical instruments. We are making a vibration on that strings or that diaphragm of the tabla. We can observe that they are vibrating. This all musical instrument shows the vibratory motion. During this motion, a change in shape and size will take place. So, let us describe the motion. We describe the location of the object by specifying a reference point. I had highlighted some of the words in red and bold font, that you must have a focus on that. Let us assume that a school in a village is 2 km north of the railway station. Now, north of the railway station is very important. The school is in the north direction from the railway station and is 2 kilometer away. In this case, we had specified the position of the school with respect to the railway station, and we had also describing its distance, that is 2 kilometer. In this example, the railway station is a reference point. Similarly, we can also define that your school is 3 kilometer from your home. So, in that case, the reference point is home and the distance is 3 kilometer. So, we could also have chosen the reference point according to our convenience. Therefore, to describe the position of the object, first we need to specify a reference point, which is also called as a origin. Let us learn a motion along a straight line. Motion along a straight line is the simplest type of motion, and the motion we will first learn to describe this by an example. See the figure below. Consider the motion of an object along a straight path. The object will start its journey from point O, very left side, which is treated as a reference point or origin. Let A, B and C are the three different positions of the object at different time instant. At first, the object start moving from origin and moves through C, B and will reach to A, and then it moves back along the same path and reaches to C through B. So, the total distance the object has covered is from O to A, that is 60 kilometer, and from A to C, that is on the backward path, and that is 35 kilometer. So, total distance travelled by the object becomes 95 kilometer, and this is the distance covered by the object. To describe the distance, we need to specify only numerical values, not the direction of the motion. There are certain quantities which are described by specifying which described by specifying only their numerical value, and this numerical value of a physical quantity is its magnitude. And from this example, you can find out the distance from the final position C of the object from its initial position, and that is what a simple difference. This difference will give you the numerical value of the displacement of the object from O to C through A. So, we can define a displacement. Displacement is the shortest distance which is measured from the initial position to its final position. So, in the example, the final position of the object is C. So, here we can see that an object is moving from O to A and then it reaches to C. So, the object has travelled the total distance of 95 kilometer, but the object is only displaced from O to C. So, the shortest distance between O to C is 25 kilometer, and so we can see that the displacement of the object is only 25 kilometers. Can the magnitude of the displacement will be equal to the distance of the travel by object? Yes, it is. If the object is moving in a straight path, in this case, we can say that the total distance travelled is equal to the displacement of the object. Displacements are used to describe the overall motion of the object and to locate its final position with reference to its initial position at a given time. Let us learn the two different types of motion. First is uniform motion and second is non-uniform motion. Consider an object moving along a straight line. Let it travel a 50 kilometer in first hour. It travel more 50 kilometers in second hour. It travel 50 more kilometers in third hour and again 50 kilometers in fourth hour. What you can observe? In this case, the object covers 50 kilometer in each hour. So, as the object covers the equal distance in equal time interval, it is said to be in a uniform motion. The time interval in this motion may be small or big. In our day to day life, we are come across the motions where the object covers the unequal distance in equal time interval. For an example, when a car is moving in a crowded street or a person is jogging in the park, you observe that the speed of the car and the speed of the person who is jogging in the park are increasing and decreasing with respect to the traffic. So, it is not traveling an equal distance in equal time interval. So, we can say that the car and the jogger will having the non-uniform motion. Let us see the difference between them. Uniform motion and non-uniform motion. Uniform motion, movement of the body along a straight line is a steady speed, but in non-uniform motion the movement of the object is having the variable speed. In uniform motion, object will cover a equal distance in equal time interval, while in non-uniform motion it covers the unequal distance in equal time interval. In uniform motion, average speed is similar to actual speed of the object, but in non-uniform motion the average speed can be different from the actual speed of the object. For uniform motion, the distance time graph shows the straight line, while in non-uniform motion the distance time graph shows the curved line. We will describe the graph in the later class. So, let us move further. How can we measure the rate of motion? We had observed that the different objects are taking the different amount of time to cover the given distance. Some of them move fast and some of will move slowly. The time rate at which the object move can be different. Also, different object can move at a same rate. One of the way of measuring the rate of motion is an object is to find out its distance travelled by the object in unit time, and this quantity is referred as a speed. The SI unit of the speed is meter per second. This can be represented as symbol meter second inverse or meter per second. The other units of motion or speed include the centimeter per second, and the larger unit can be measured in terms of kilometer per hour. To specify the speed of an object, we only require its magnitude. The speed of an object need not to be constant. In most of the cases, the different objects are having the non-uniform motion, and therefore, we observe that the speed to be measured in terms of average speed. The average speed of the object is obtained by dividing the total distance travelled by the total time taken. So, here is the equation. Average speed is equal to total distance travelled divided by total time taken. Let us denote the different symbols for speed, distance travelled and the time. We define the speed in terms of v. We define the distance travelled in terms of s, and the time can be expressed with t. So, we can say that v is equal to s divided by t. Now, here is your activity to be done by you in your notebook and submit it online. List the object around you which are rest or in motion. List at least 5 objects which are in rest and list at least 5 objects which are in motion. Also describe its type. Second activity for you is take a meter scale and measure the different distance in your home. Walk from one end to another end in your room and find the distance travelled by you and note your displacement. Also note the time taken by you to measure the taken by you and then find out your average speed. Another example activity for you is to find out the distance between Navsari and Surat, between Navsari and any of the city you wish. If you travel from Surat, find the distance total travelled by you and your displacement. If you travel to Surat from Navsari and again back to Navsari, then again find the total distance travelled and the total displacement by you. All of you are having a vehicle in your home. Your vehicles are fitted with odometer and speedometer. Ask your parents about the functioning of odometer and speedometer and write its application and how this odometer and speedometer will work. In next class, we will learn about the graph, that how to